saw that in class there, something like that. Does that make sense?
Hmm.
Okay, now there's four possible triangles that you can draw depending on which quadrant you're in. And I call it the reference bow tie because it kind of looks like a bow tie if you've been to a formal dinner. But depending on which quadrant you're in, these are like you're guaranteed to get one of these as your triangle. So in this case, your triangle is left one, -1, up square root of 3 like that. So this is all about building the triangle and then calculating the hypotenuse. So to calculate the hypotenuse of any right triangle, that's where you're using your a squared plus b squared equals c squared, and you're solving for c in this case. Uh, could you help me out with that? Square root of 3 squared plus -1 squared equals c squared. What would the value of c be?
2.
2. Okay, now the angle is always the angle that's made with the x-axis. Okay, so the when you're finding, for example, the sine of theta or the cosine of theta or the tangent of theta, you have to know that that angle is the one that's made with the x-axis, even though there is this other sort of standard angle here. It's actually the one that's made with the x-axis that you're looking for. Now, if I sent you the trig cheat sheet that I really recommend for this course, if not, I don't know if
I
anyone
don't
would
think
drop it.
so.
So this sheet right here, this is all the formulas you need in trig. It looks very overwhelming at first glance, but it is everything, and you will learn all of them at some point. I like I like having it printed out. I would almost mandate that be printed out for students because I think you really need to have that. And you'll see on page 1 there, the first kind of grouping of things that you have to know is exactly what we're doing here. Sine, cosine tangent, cosecant, secant, cotangent. You got to just know these. How do you feel you are at you've memorized or knowing these at this point?
Hmm?
How 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 do you feel you are at knowing these? Do you feel like you've got, these down, what sine is, cosine is, tangent specifically?
Yeah, I know those pretty well.
Excellent, excellent. Okay. So let me just grab the triangle here. And let's see if we can do a few of these here together. So the sine theta is opposite over adjacent. What would that be in this case here?
Um, it would be √3/2.
So yes, √3/2. And then cosine theta is -1 over -1/2. How about tangent of theta? What would that be?
√3/-1.
Very good. Now, this one you should rewrite as -√3. And the expectation is um, that you do that. All right. So now the next three really have to be done in relation to this. So it does matter. Cosecant theta is the reciprocal of sine theta. You probably heard that in class. It is the hypotenuse over opposite. I think that's hard to remember. So I remember it as the flip of sine. You'll find that there's so much to remember in this course that it's better if you can find, like linked ways to remember stuff. Did you guys talk about how to rationalize this in class, or maybe that's something you've already done before?
I have a general idea of like how
Okay,
to
so you always multiply the bottom by the root, and ends up being 2√3/3. So this is correct. This is the answer, but it's not in the right form. I mean, it'll make the rules. That's just, you got to remember that they're telling you, hey, you got to rationalize. Secant of theta is the reciprocal of cosine. So 2 over -1. And then you do want to write that as -2. Cotangent of theta is the reciprocal of tangent. So it's the flip of this. That's why it's sometimes good to have a bunch of them, different forms out. You flip it, and then again, you have to rationalize it. You will be doing rationalizing over and over again in this course. one of the reasons students struggle in this course is they're not very good at algebra and they get caught up in how to like manipulate these things. So I believe you're a pretty good algebra student, but I think you'll be okay. But sometimes there's a lot to do after you get through the trig part of this.
Hmm.
So the setup here is you got to draw it in the right quadrant. There's 4 possible triangles depending on which quadrant you're in. You always find the hypotenuse or the missing side, could be a leg. You've got to label these correctly. Sometimes the signs can be in the wrong place. And then you start out with sine and cosine, build tangent, then you build the reciprocal ones from that.
Okay.
There's a recipe basically each time. So out of that grouping 11 to 30 there, is there another one that you would like us to work on? Ones that I might recommend would be like an exception. Uh, to this, like something like 22, 20, 24. Those are exceptions. We could look at some of those. But the other ones are all triangles.
Yeah, if we could look at like 22, that'd be great.
Okay. So 22 is unrelated to what we just did. Like there is no triangle in 22 because this point minus 50 is 1, 2, 3, 4, 5. It's right there. There's no triangle. This is X, this is Y. This is where you've got to know all the variations on sine, cosine, and tangent. Okay, so the X value is cosine, the Y value is sine. So the cosine in this example here, did I put theta? I did put theta in all those. The cosine of theta is -5. The sine of theta is 0. Right. And actually I did these in the wrong order. We should have done sine first, then cosine. The reason you want to be consistent with your order is that sine over cosine gives you tangent. Tangent of theta is 0 over -5, which is 0. Is that okay?
Yeah. When would I know if it's undefined or not?
That's what we're going to talk about. So the cosecant of theta is the reciprocal of sine. Now this is probably uncomfortable, but 0 is really 0 over 1. So when you flip it, you get 1 over 0. Division by 0 is not allowed. This is when it's undefined. It's undefined when it's division by 0.
Okay.
Cosine of, sorry, not cosine, secant of theta is, and again, you might have to rewrite this as a fraction, is 1 over cosine of theta, which is the reciprocal. So it's 1 over -5, which is -1/5. Sorry, this is undefined. Here to say that. Cotangent of theta is the reciprocal of tangent, which is -5 over 0, which is also undefined. What you're noticing that I'm doing, which may be different than what you're seeing in the classroom, is that I do not recommend trying to remember what I'm about to put in from the reference sheet. There is kind of a limit to what the brain can remember, and this is duplication of what you already know. Like, yes, sine is the Y value, cosine is the X value, tangent is Y over X. The stuff on the right, I feel like is redundant. It's better to remember that cosecant is reciprocal of sine, secant is the reciprocal cosine, and so on, rather than trying to remember that because it's extra information that is already encoded into what cosecant, secant, and cotangent are.
Yeah.
That is at your discretion. Some students go so far as to remember this right here, which works when it's a triangle, doesn't work when it's a point on the axis. So 11 through 30, you're either going to get a triangle or you're going to get something on the axis. When it's on the axis like this, that's when you're going to have some of these undefines. What I don't recommend is trying to like remember like, oh, if it's on the x-axis, then sine Sorry, cosecant and cotangent are undefined. It's just too much to remember. Just work it out, and if it's division by zero, it's undefined. Are there any others in 11 through 30 that you would like us to look at?
I don't think so. I just mostly wanted to like review the concept to like make sure I understood it.
Okay. I feel like we should do one more, or at least have you try one more. So I mean, I'm leaning towards something earlier. Well, so 11 through 18 are all nice triangles. Um, and then the last grouping, like 26 through 30, they're okay. Like what I'm not seeing is something where they tell you something that just doesn't work out nice, like -2. We already did that, so let's do it different. Let's go like 2, 3, for example, 2, -3. So where is that? That's down here, and this is the triangle. This is 2, this is -3, and the hypotenuse is the square root of 13. Okay, and the angle is there. So this type of problem, you have to rationalize a lot. Like sine theta is -3 over square root of 13. You have to rationalize that. Cosine theta is 2 over square root of 13. Like I feel like this is more what you might see because you were mentioning that you don't get these problems aren't hard enough for your exams.
Yeah.
And so like these all the ones given kind of work out nice, I guess. Um, so when you rationalize these, you're multiplying the top and bottom by the roots. -3 root 13 over 13. So it's 2 root 13 over 13. Tangent, yes, this is where you gotta like it is good to know some of the variations on it because if you're using these two answers or even these two answers, it could be more complicated than just doing y over x. So it is in some cases good to know that it is just that. But let's see that it works, if we use the original sine and cosine is -3 over root 13 over 2 over root 13. Is it -3 over 2? Yes, it is, because when the bottoms are the same, it just becomes those two values. Now,
Okay.
cosecant of theta is the reciprocal of sine. So you could take the reciprocal of this, but it would be better to take the reciprocal of the original because the original is already rationalized. The root's already in the top. Whereas if you flip this answer here, the final answer there, you're like, all right, well, let's start with 13 over -3 square root 13. Well, now you have to rationalize it, and you will get the same answer. You get 13 root 13 over -3 times 13. 13's cancel. You get the same answer, but now you got more work to do. So it's your choice. Like you can choose to flip this, or you can choose to flip the intermediate result. That's why it's good to have them. Same thing here with secant of theta. Better to take the reciprocal of the intermediate answer, 2 over root 13, rather than this one here. Same with cotangent, since it's nice, that. And you do want to move the sign up, so this is really -2/3. Same thing with the cosecant, that negative really needs to go up there like that.
Okay.
So why don't I have you try one here, if that's okay? Um,
Yeah.
so let me give you the point -4, -5. And go ahead and come up with sine, cosine, and tangent of all of those, please.
Sine would be -4 root 41 over 41.
Right, good. And that's a weird answer, right? But that's what it is. Good. How about a
Yeah.
cosine? Sorry, no. I allowed you to talk me into that. Um,
Hmm?
no. So this one's in fourth quadrant, right?
Third.
For third, sorry. You're right, third. And so this is root 41. Sine is opposite over hypotenuse. This should be -5.
Oh, okay.
So that may change your answer for cosine, or it should.
Yeah, that would be -4 root 41 over 41.
Good. All right. And how about the tangent?
It would be -5 over 4.
Here's what you said. Is that what you meant?
Oh, no, it'd be 5 over 4.
Yes. Good. And that little thing will get you marked, marked up. How about cosecant theta?
Um,
Or you still need some more time?
I still need more time.
Okay. Yeah, take it.
Would it be -41 root 41 over 205?
So like, remember it was better to use the intermediate answer. Like sine of theta is really -5 over the square root of 41. And it's better to
So
take
just be
that.
root 41 over -5.
Yes, and that negative really should come up to the top. So if you can do that in one step, that's better. Yes, so that's why you got to keep those intermediate.
Okay.
About secant of theta.
It would be -root 41 over 4.
Good. And then tangent of theta.
4 over 5.
Yeah. You really want to use that reciprocal stuff. That's really the best way, in my opinion. Um, so keep that in mind. All right, good job there. Like, you would definitely want to do more from that grouping, but we should move on to the next grouping of questions if that in fact is assigned or you have questions out of those.
Mhm.
Do you have to do those?
I don't have any other questions like that right now, but
Okay, I want to build something for you, if that's okay. This is important for signage, or do you have other stuff you want us to look at?
no, we can work on
Okay, so there's this acronym ASTC. Have you seen that yet?
ASTC.
Yes. That's what I'm
Uh,
asking, like how much you know or have seen about this. It's really important for the rest of this course.
not really.
Okay, so the way students remember this, or the way teachers say it, is all students take calculus, which is not true, but you need a way to remember these letters. Okay, and I want to talk about what they mean, what they stand for. Okay, but that's how people students remember it. All students take calculus. There's probably another way, but that's what it is. So A means in quadrant one, A means that they are all positive. And all refers to sine and cosine, which leads to tangent being positive because tangent is the ratio of sine and cosine. Cosecant being positive because cosecant is the reciprocal of sine. Secant is positive because it's the reciprocal of cosine, and then cotangent is positive because it's the reciprocal of tangent. But when it says A, all positive, it literally means all of them. But for kind of the shortcut to not remember everything, it's sine and cosine. Is that okay for starters?
Yeah.
All right, now I'm going to redraw it here. A, S, B, C, quadrant 2. S means that sine is positive, okay? And that is the only thing that is positive, okay? But really, that also implies that cosecant is positive because cosecant is the reciprocal of sine. What it really means, though, is that cosine is negative. So this letter tells you what's positive in this quadrant. It tells you also what is negative. Cosine is negative, which means that tangent is negative because tangent is the ratio of sine to cosine. If one's positive and one's negative, then tangent's going to be negative. Because cosine is negative, that means secant is negative because it's the reciprocal. Tangent is negative. That means that cotangent is also negative. So this one letter tells you all this stuff here. And you've not
Okay.
seen this yet in class.
No.
Okay, this is a good thing. I mean, I like giving you new information because this is more of an answer. So the third quadrant here, P stands for tangent. Tangent is positive, which means that cotangent is also positive because cotangent is the reciprocal of tangent. But the A, the S, and the T and the C refer to sine, tangent, and cosine. They don't refer to the other ones, just sine, tangent, cosine. But because tangent is positive, cotangent, which is the reciprocal, is positive. That means that sine is negative and cosine is negative. Because the ratio of sine and cosine, negative over negative, is a positive
If
down here. And since sine is negative, cosecant is negative because cosecant is the reciprocal of sine. Secant, which is the reciprocal of cosine, is also negative. So from this one letter, we gain all of this. And this is really the best way to learn stuff. I've seen medical students do this at countless coffee shops over the years. They remember one thing that leads to another thing, leads to another thing, leads to another thing, and so on. They don't try to remember all of this. It's just not possible. Last one here. So for C in quadrant 4, C means that cosine is positive, which means that the reciprocal of cosine, which is secant, is also positive. Sine is negative. Since sine is negative, tangent, which is the ratio of sine to cosine, is a negative and a positive, it's also negative. And then because sine is negative, cosecant is negative. Because tangent is negative, cotangent is negative. So the idea is that the letter tells you what's positive, and then from there, you also know what is negative, or you can establish what is negative from all that.
the what?
The letter tells you what is positive. It also establishes what is negative. That was the whole point of going through each of these. And then you
Yeah.
can figure out all the rest. So we need to do some examples if you're okay with this
Uh-huh.
to like make this clear. So you're gonna see me draw this over and over again. A, S, P, C. And I'll keep it really simple for the starters. Let's say tangent of theta is greater than 0. Which two quadrants is that in? Well, it's in quadrant 1 because they're all positive. It's also in quadrant 3 because tangent is positive in quadrant 3. Is that okay for the moment? All right, now where's cosine theta? Where is it? Where is it positive? Well, it's positive in the first quadrant because all are positive, and then it's in the fourth quadrant because that's where the C is. So if I asked you where these are both true, what would you say? Which quadrant are they both true in?
The first quadrant.
The first quadrant, quadrant 1. All right. So now let's increase the difficulty a little bit. Let's say I ask you where sine theta is negative. So A means they're all positive, so it's not there. S means it's positive, so it's not there. So it must be the third and the fourth quadrant because tangent is positive, but everything else is negative. Cosine is positive, so everything else is negative. But when I say everything else, it means other one. Is that okay or not?
Uh, yeah.
It's okay if it's not. I mean, the harder ones are when they're negative. So like if I asked where sine theta was positive, you'd say, oh, it's the first and the second. So therefore it must be the third and the fourth that are negative because it's either positive or negative. Where is tangent of theta greater than 0? Which two quadrants?
1 and 3.
So where are they both true?
1. Oh wait. 1, 3.
Both of these. Both of these. So it has to be in quadrant 3 where the double check is. Because tangent is positive in the first quadrant, but that's the only thing that's working there. Like we're trying to figure out where there's the overlap in them. Um, this is kind of what is in 31 through 50, but it's a more advanced idea than this. Let's try another one here. Cosecant theta is greater than 0. Which two quadrants is that true in? And it's always two quadrants.
Cosecant.
Yeah. And remember, cosecant is really like
4.
sine. Say that again.
4 and 1.
It's definitely one, but remember, it's really like sine. So where is sine positive? What
Oh, it's
quad?
sine. Sorry. 1. I mean 2.
And two. Yes. Okay. So now where is secant of theta less than 0? So secant of theta is 1 over cosine. So you really treat secant like it's a cosine.
It would be 4.
It's always two quadrants.
4 and
It's the
1.
other. Yes. So where's the overlap? It would be quadrant 1, right?
Yeah.
So the question, I know I've been asking, but the question be, in which quadrant is cosine theta greater than 0 and secant theta less than 0? All right, so let me give you a problem here to try. Uh, let's do it. So let's say sine of theta is less than 0 and cotangent of theta is less than 0. I need to just step away for 30 seconds, but give this a try. There's only one quadrant where they are both true, but I will be right back. Okay. Do you have an answer for me on this one?
Um, yeah, is it 4?
All right, let's take a look. So sine is negative in the third and the fourth. Cotangent is really tangent, 1 over tangent. Tangent is negative in the second and the fourth. So yes, it is the second and the fourth. Good, really good. Okay. Um, so the way this works in regard to problems that you've been doing already is it might tell you something like this. It might say that the tangent of theta is 4 over 3 and the sine of theta is less than 0. So what this means is that you have to figure out, well, which quadrant are you in? And this time I'm not telling you like that it's less than 0 or greater than 0. I'm just giving you the what it is. This is greater than 0. So which two quadrants could that be? Which two quadrants could this one be?
Is the answer 3?
It is. And if you recall, that reference triangle looked like this. Now, if you label the sides, I'm going to label the sides A, B, and C. Can you tell me the value of A and B in this triangle based on this right here?
Find sine.
Nope. What's the value of A and what's the value of B? Based on the fact that tangent of theta is
B
4
is
over 0.
4, A is 3.
Okay, so that's the classic answer here. And the problem is the problem here is that um you don't go if it's 3, that's like you're not getting to this point down here. You're going left 3 and down 4.
Mm-hmm.
So you have to keep that in mind. Like even though this is the right answer, it's the reduced answer.
Yeah.
Okay. So now could you find that missing side for us, please?
Five.
It is 5. Now the hypotenuse is always positive. That's something to remember. Might be
Okay.
important, might be important later on, but yeah, it's always positive. Um, the next thing here is that you would be asked, and we'll just, we'll do this like we've been doing, sine theta, cosine theta, and tangent of theta, like that. So could you get those values for us, please?
Sine is negative 4 over 5.
Okay, negative 4/5. How about cosine?
Cos is negative 3/5.
Yeah, we want to like I'm not big on like this, but we do want to pronounce it correctly just because you're going to do this over and over again. Cosine, not cos. Even though it's COS, it's pronounced cosine. I don't make the rules, sine, not sin. Sin's a different class altogether. SINE. That you're going to have issues if you don't pronounce them correctly down the road.
Okay.
And then we already have this one. Like sometimes we overthink it. It's like, wait, you already have it. It's 4/3. Okay. So this is another style of question that you're going to be asked. We're going to have to find, you have to draw the triangle based on the given information and then do the sine, cosine, and tangent stuff.
Okay.
All right. Let's try another one here. let's say the cosecant of theta is minus 15 over 8. And we know that the cotangent of theta is less than 0. All right. So which, and this is where you see, like, you'll see students all the time trying to figure out, well, which quadrant are you in? So I'd like you to try to figure that out, please.
Secant is for cosine, right?
Uh, yes, a secant is 1 over cosine, but the S refers to sine and C refers to cosine.
So cosecant is for sine.
Yes. Cosecant theta is 1 over sine theta.
It would be 2.
Okay. Remember, if cosecant is really sine is negative, that means you're either in the third or the fourth. Cotangent is really like tangent, so if it's negative, it's going to be in the second or the fourth.
Oh, so it'd be the 4th.
Yes, and that matters. Like if you do the wrong quadrant, you will get every answer. Not every answer, you get a lot of the answers wrong. Okay, so again, A, B, and C, could you tell me any of these based on this here? And what I would recommend doing is saying, okay, cosecant is this. So if I take the reciprocal of it, sine of theta is really the flip of it, minus 8 over 15, or 8 over minus 15. That might help you to correctly identify these. And actually, I've used the wrong number here, especially if we're gonna go further on this. Let me adjust it here.
What do you want me to spell for this one?
I'm trying to get you to tell me, like, whether A is 8 or -8, B is 8 or -8, C is, what these values are. Trying to get you to give me the information from the triangle.
Oh. B is 8, C is -17.
So yeah, B is -8, C is 17. And then when you solve for A, well, actually, why don't you solve for A using the Pythagorean theorem for us, please?
A is 15.
That's 15. Good. So now that you have the triangle, sometimes it's good to just, reset with the triangle. 15, -8, 17. You can now find all of the possibilities, sine theta, cosine theta, tangent of theta, cosecant of theta, secant of theta, cotangent of theta.
Sine is -8/17. And then cosecant is -17/8. And then cosine is 15/17. And then secant is 17/15. And then tan is -8/15, and cotangent is -15/8.
So this is the type of problem you would be expected to do based on this. And it's kind of a more challenging example of yeah, this is the kind of thing. So hopefully that helps. I would recommend printing out that cheat sheet. It's not really a cheat sheet, it's just a reference sheet for the entire course. You'll definitely be using that a bunch here. So we are out of time today.